Welcome back. On today's lesson again, it's still Joe Monday for Math 3, the tutor. On the previous video, we did a bit of arc length. As I said, I will give you access to Math 2, so you need to do some revision on derivative. Okay? So today, it's gonna be a lesson just about the volume of a solid of revolution. Okay? So we're gonna have a look on a disk method when you have to do a revolution to calculate the volume of a specific solid, if it's in X revolution or in Y. So we're gonna have a look, but we are going to apply disk method. So as I said, our lesson, it's gonna be all about the volume of a solid of a revolution. So we're gonna apply a disk method. Okay, so therefore, let's say for instance, they give us our coordinate. You have your X, you have your Y, and then this is our body, for instance. Let's say this is a body that we have to calculate the volume of this body in the revolution. Okay, so as you can see, for instance, if we have to consider that this body is in X, Y, or XS, okay, and therefore we're gonna take a specific part here, okay, a limit. So you're gonna have, for instance, B, A, and B, okay. So we're gonna consider this part here to calculate the revolution of this body, okay. So for this case, this body we consider to be rotating. It's doing the rotation in X axis, okay. So how do we calculate when our body is doing a revolution in X axis? You have to apply our volume of this body is going to be pi, the integration of between B. B is that limit that we choose of that function, okay? And then it's going to be y squared d dx. That will be our revolution of that body. But what is y? Y, it's our radius. Y will be the radius of this body, okay? And then this differentiation, this dy or ddx, this will be the I of this revolution, okay? So the thickness of this revolution, okay? So in the case where they give us a body or they give us a function and they say this function is rotating in x-axis. In x-axis, when you have to apply your disk method, this will be just the formula you have to apply. But make sure that you have a y function. So in the case now, we are doing the revolution of the body and we say this body is rotating in the y-axis, okay? So if you are doing with this case, remember we say it's rotating in y-axis. So we're gonna choose again, we take a specific limit, okay, between A and B, okay? So therefore, what is the formula you're going to apply in order to calculate the volume of this body when rotating in y-axis, but using this method? It's going to be V, it's going to be equal to pi of B A x squared d dy, where your x is the radius, okay? And then this is going to be the I of that body. So basically what you need is just to take the two formula. You need to know my body, is it rotating, the revolution, the volume that I'm calculating, is it in y-axis and is it in x-axis? So we're gonna have a look on some two examples so that you understand how to approach this kind of problem when you're looking for the volume of a solid of a revolution in x or y. The difference is just in formula, but you will see what's going to happen when you're going to do an example. So we're going to have a look on an example, which is already a question under your tutorial question. Question 6.1. Okay. So as I said, the first thing to check is the revolution, which is a x-axis, when you're applying your disk method. So we know that for x-axis, our volume will be given by what? Pi AB y squared d dx. Okay, so the first thing we have to check is what will be our function y. Our function y already we know this will be our function y. Okay? So what will miss again? We have to determine what are their our limits. We have a and b. We need to determine them. Okay? So when you look here, you can see that you have y and x. So already we know that the first limit is x. So we need to determine the second one. Okay? How do you determine it? Look here. They give us y equal to 0. So we're going to come with this y here, we say. Okay? When y is equal to 0 under this function, what will be the function, the value of x? So we're going to have 0, which will be given by 2x squared. Then you can see that x will be equal to what? 0. So this will be the second limit to this function. So when you come here, you apply your formula, you have what? Pi under the limit of what? 5, which is the bigger one, and 0. And then the function of y is what? 2x squared ddx. So this will give us pi 5 and 0. So we have 4x 4 to the power of 4, 2 times 2, then ddx. Okay? So, and again, how do we do a calculation? From that, you can see that our volume will be given by pi, the limit of 5 and 0, 4x 4 ddx. The integration, you want to have 4, you keep them as the constant, and then you have x, 4 plus 1, because it's a power, 4 plus 1 will give you what? 5, then you divide by that power, 5, okay? Then you check for their limit, okay? Once you do that, now you come here, you have the limit. You're going to have pi 4, 5 to the power of 5 over 5 minus 0, because already when you substitute 0, it's 0. Then the answer will be 200, 500 pi. Okay? And then we're going to have a look on this example 6.3. Okay? So the first thing we check is the revolution, x-axis. And as we say with x-axis, the volume will be given by what? Pi b a y squared ddx. Okay? So the first thing that we need to determine is determine our y function. So you come here, you can see this is y squared. So our y will be given by what? X cubed to the square root of that. So this will be our y function. Okay? So now, what will be our x limit? We have already the first limit. We need to determine the second limit. But now you can see they give us y is equal to 0. So we're going to use this y is equal to 0 to determine the second limit. Okay? So when you look here, you have y squared is equal to x cubed. So when y is equal to 0, x cubed, okay, x will be given, it will be equal to 0. So 0 will be the second limit. And then you come here, you say the volume will be given by pi between 2 and 0. The function that we got, it was what? X cubed, all of that to the power of 2 ddx. The power, conserve the square root. Then you remain with pi 2, 0, x cubed ddx. The integration of this will give us what? Pi, you keep x cube plus 1, 3 plus 1 plus 1 give us what? 4. And then you say 4 over 4 under the limit of 2 and 0. Okay? So once you have determined that, you come back here and then you find out that our limit, our value, which is going to be given by pi x to the power of 4 over 4 under the limits of 2 and 0. Our limit will be given by pi 2 to the power of 4 over 4 minus 1, and this will give us 4 pi. And then we're going to have a look on exercise 6.2 under the tutorial. And as I said, it's all about look at the axis, and in this case it's a y-axis. From our formula, we know that it's going to be pi b and a, our limit, and then you have x squared d dy. What will be our function x? You come here, you check, it's y function, then you need to change it to x. So if you have to change it to x, you're gonna see what? You have these two will go down. Okay, so we're gonna have y over 2 of x cubed squared. Therefore, our x will be given by the square root of y over 2. Can you see that? So this is our function x. Now we have to determine the limit of y. Already we have one limit, which is y is equal to 0. Okay, so we need to determine what will be the second limit of y. So as you can see, already they give us the first case to us y when x is equal to 0. When x is equal to 0, we will find out that y is equal to 0. Okay, so when x is equal to 5, what will be the value of y? So you come here in the function, you say this is equal to 2x squared. When x is equal to 5, you're gonna have 2 to the power of 5 squared. Then your y will be given by 50, and this 50 will be the second limit of the volume. Okay, so therefore you take your formula, you apply it. Can you see? You have pi between the limit of what? 50 and 0, and then our function, as we say, is going to be y over 2, all of that squared, dy. This cancel that. So if that cancel that, finally we want to remain with a function that will be given by pi in the limit of 50 and 0 of y over 2 dy. The integration of this will give us what? Pi y squared, because 1 plus 1 squared, over 2 times 2. 2 times 2. This gives us what? 4. Then you take it 4 under the limit of 50 and 0. So you determine your limit. Pi 50 squared divided by 4 minus 0. We substitute the 0. And then you're going to have 625 pi as the volume of this function. Okay, so in the next video, what we're gonna do, we're gonna go and have a look on the shell method, because we can apply a shell method with this example that we have done to get the same answer. You get the point? So we can apply the same method with the same question, but using our shell method. There will be some function when you have to solve it, you have to apply the shell method. Okay, so our shell method will be in our next video that we're gonna provide. And as well, have a look on our website. We have all the content, your textbook, your additional formula sheet that you can use in order for you to prepare for your test or everything. But if there is any question, make sure that you ask in the group, and then that's it.